Hey students, it's me, Mr. Fitz, and I just wanted to make a quick video. Well, I'm not sure how quick it's going to be. I want to make a video about the practice test. So I'm going to go over the solution guide. I'm going to go over, probably all the problems, but I probably will take a deeper dive into one of them. So let's take a look. And so if you wanted to fast forward through some of the problems that you're good with, that's totally cool. So here we go. Let me just zoom in a little bit on this question here. Okay, so it's too much. Question one, in the diagram below, which single transformation was used to map triangle A onto triangle B? So this is the pre-image, this is the image. As you can see here, I sketched what looks like a 90-degree angle. And yeah, so if you just connect, and it's about, wasn't clear that it was about the origin. So interesting that they should probably cite that well, they didn't even have to say anything. But anyway, it looks like it's a rotation about the origin of 90 degrees. And so if I connect, say this point, which is being mapped onto this point here to the origin, yeah, it definitely looks like a 90-degree rotation. It's not a reflection of any kind because the order of the points is going in the same orientation. So, and it doesn't look like a translation. So that's definitely a rotation. All right, let's look at this next one. So number two, quadrilateral ABCD is being mapped, is being graphed on the set of axes below. When ABCD is rotated 90 degrees in a counterclockwise direction about the origin, its image is a quadrilateral A prime, B prime, C prime, D prime. Is distance preserved under rotation? And which coordinates are the correct for the given vertex? So distance being preserved, as I noted here, that's just a mathy way of saying that this shape hasn't changed size. So why can't they just say the shape hasn't changed size? I don't know. But the shape is definitely not changing size. So distance is preserved. So it's definitely one of these two, crossing off those two. And then I put another note down here. If it were, say, A getting mapped to 6, 2, that's over here in quadrant 1. So that would have to be a rotation this way, 90 degrees clockwise, but they said it's going this way. So I actually performed the rotation here. You actually didn't need to do that. If you want, you could use patty paper to just kind of figure out where it's going, because I was able to eliminate all these other answer choices without even figuring out which point was correct. So the correct answer is yes, and B, -3, 4, which is right over here. So B is being mapped over to here. Okay, that's number 2. So let's go up to number 3. Okay, in the graph below, the graph below shows two congruent triangles, A, B, C, and A prime, B prime, C prime, which rigid motion will map A, B, C onto A prime, B prime, C prime. Please do this every single time you see one of these transformation questions. Go ahead and draw these arrows from A to B, B to C, C back to A. Notice that's going clockwise. A prime, B prime, C prime. Notice that's going counterclockwise or anti-clockwise. So let's see what we can do. It has to be a reflection, right? Because the letters are being flipped, right? They're being flipped around once. So if you remember the letters on your shirt, I'm going to go backwards in the mirror. It's true. Rotation, definitely not a rotation. That's a direct isometry, not going to work. Translation, also direct isometry, not going to work. Rotation, not a rotation. All of these would keep the order of the points the same. It has to be a reflection. I don't even care like what the reflection is. I don't have to do anything else. I'm done. It's a reflection over the line y equals x, which, by the way, is this diagonal line here. So if I go ahead, if I wanted to sketch that, it would look something like what? Here, it would look kind of something like this. You know, this kind of like diagonal line there. That's not very straight, but anyway, get my point. All right, let's take a look at the next one. Number 4. All right, this is a symmetry question. Which figure always has exactly 4 lines of rotation? 4 lines of reflection, I should say, that map the figure onto itself. I sketched all of them. I'm going to go in backwards. Well, I'm just going to go in backwards order. Equilateral triangle. That has 3 lines of symmetry. So if I flip it over this line here, then this point's going to be mapped onto this one. This one's going to be mapped on this one. This one's going to be mapped on this one. Octagon has 8 lines of symmetry. Notice the pattern here, 3 sides, 8 lines. The pattern breaks here for a rectangle. That pattern only works for regular polygons, meaning all the side lengths are the same length. For rectangle, it only has 2 lines of symmetry. That might seem confusing to y'all, but if you take a piece of paper, like a rectangular piece of paper, like this, and I fold it over diagonally, it's not going to be mapped onto itself. Like if I try and fold the diagonal, it doesn't map onto itself. So like that's not a line of symmetry, so that's not going to work. But a square does have 4 lines of symmetry. It has these 4 here. So 4, that's a regular polygon. A square has 4 lines. Okay, making good progress. Number 5, a sequence of transformations maps rectangle A, B, C, D onto A double prime, B double prime, C double prime, D double prime as shown below. Okay, again, check the order of the points. This one's going clockwise. This one's going counterclockwise or anti-clockwise, right? And then this one's still going counterclockwise. So what I said in my little notes here, because the orientation goes from counterclockwise to clockwise first, clockwise, the first transformation must be a reflection. This is a reflection, looks like a reflection over the x-axis, or the line y equals 0, if you will. Then the orientation stays the same. So that must be some sort of rotation or translation. It doesn't look like a translation. Looks like it's some sort of rotation. Let's take a look. Reflection followed by translation. No, it doesn't look like it's that one. It's definitely not these two, because it has to be, well, it's definitely not this one, because this is 2 direct isometries. And it has to be a reflection first, right? We figured that out because it's flipping this way. So it's not these 2. It has to be this first one here, reflection followed by rotation. Okay, again, similar type question. Identify which sequence of transformations could map pentagon A, B, C, D, E onto pentagon A double prime, B double prime, C double prime, D double prime, E double prime as shown below. Notice this is clockwise, counterclockwise. Since the orientation flips, can only be 1 reflection, but not 2, right? 2 reflections. If I flip it once, the letters go backwards. If I flip it back, they go back to it being a direct isometry, right? So we learned about that. So it can't be 2 reflections, it can't be number 4, and it can't be 1 or 2. It needs to have 1 reflection and only 1, or it could be any like odd number of reflections. You can't have an even number of reflections, because right, if I flip it 3 times, 1, 2, 3, it's back to backwards again. So there's a line reflection by line, nope, not that one. So it's gotta be number 3. All right, last one, number 7. Number 7 here, again, you check the order of the points. A, B, C is going this way. D, E, F is also going the same way. So since that's like some sort of direct isometry, it looks like some sort of rotation. If it has to be a sequence of transformations, well, then it's gonna be, it would have to be either 2 reflections, or it could be like a translation and a rotation. It could be, which kind of looks like that. It can't be 2 translations, because then, you know, these points would still be pointing, like the A would still be like up top here. So it looks like it's like a translation and rotation, or maybe 2 reflections. So this number 8, this is one I'm gonna do a little bit more work on. So I'm gonna pause right now and we'll take a look at number 8.